The graph of y equals f of x is shown below, where f of x is 4 cos to the power 4 2x, and a is the smallest root of f of x for positive values of x. We want to show that 4 cos to the 4 2x is equal to this expression here. Now we know that cos of 2a is 2 cos squared a, take away 1. So it follows that cos squared of a is equal to cos 2a plus 1 divided by 2. In fact, what I'm going to do instead of doing that is I'm going to say 2 cos squared a is equal to cos 2a plus 1. So if we look at this, that's 2 cos squared 2x squared. So it follows that that should be equal to cos 4x plus 1 squared. And that would give me cos squared 4x plus 2 cos 4x plus 1. Now my cos squared 4x here, just following this again, should be equal to cos 8x plus 1 all divided by 2. So, if we put this all over the common denominator of 2, we have cos 8x plus 4 cos 4x plus 1 plus 2, so that's plus 3. And that's exactly what we were trying to show just here. Hence we want to determine this integral. Well, the integral is going to become half of the integral of cos 8x plus 4 cos 4x plus 3 dx. So that's a half of, integrate cos, we get sine, so sine of 8x over 8. Then we've got 4 sine 4x over 4. Add 3x plus a constant. So that's going to be sine 8x over 16 plus sine 4x over 2, because these 4's cancel, plus 3x over 2 plus a constant. Determine the exact volume of the solid generated when the region bounded by y equals f of x, y equals 0, x equals 0 and x equals a is rotated through 360 degrees about the x-axis. So that's this area just here. Note there's only 2 marks, so we can use the calculator for a lot of this. So what's this value going to be? Well, we know that cos of pi by 2 is 0. So it stands to reason that this must be at pi by 4. So our volume is going to be pi times the integral from 0 to pi by 4 of y squared dx. And in this case that's going to be 4 cos to the 4 2x squared dx. So we're going to do that on the calculator, obviously. So let's stick the pi in front over here. So I'll put pi outside, and then we've got 0, and up here we need to have pi by 4, and then in here we're going to have 4, and then we've got cos of 2x, and that needs to be to the power 4 with the whole thing squared. I've just got the wrong bracket there. Let's just make sure with the brackets. So we've got 1, 2, 3 open and 1, 2, 3, 4 closed. So might need another open. And let's just check. So this is the 4 cos to the 4 2x. We're squaring that. Okay, so that should be okay. And it wanted exact, so standard. And execute, and it's thinking about it. And okay, so it's given us quite a big expression, and some of this actually simplifies. That's because we're in degrees. You've got to be so careful with these things. We need to be in radians when we're doing this sort of calculus. So let's just go back there. Now we're in radians and execute again, and that's much better. 35 pi squared over 32.